Okay, so let's start by identifying what we're squaring here. So can anyone tell us what this is? How do we call it? The terminology is important because you're going to read problems or you're going to have questions and you have to be able to understand what the question is asking. So what is a plus b called? What is the name of a quantity plus another quantity?
Addition.
Yes, but beyond that, true, it's an addition of two terms. How do we call this? It has a special name.
Is it a factor?
Awesome. Very good. When we add two terms, this is called a binomial. Very important to remember that. Perfect. Okay, so now the question is, how do I, for now, just once, and hopefully we don't need to do this again, we are going to FOIL a plus b. Unless somebody remembers what a plus b equals to. Not to be confused with ab. What does a plus b squared equal to? Does anyone remember? Yes, please.
A squared plus 2 is AB plus B squared.
Of course. Okay, so now let's see how we get to that. Since only one student answered, let's go through it. So what do I have with a plus b squared? What does it mean, really, before we get to that?
A plus B times.
Awesome. Thank you very much. Indeed. So now what do I do next? How do I multiply two? What are they again? Two binomials. Correct. How do I multiply two binomials? The method is called? Very good. So let's do that. A times A plus A times B. Not yet. Plus B times A, but you're correct. Very good. And plus B times B. Do you all agree with this? Do we agree with this? Yes. And now we have to combine these two. So I have to write a squared. And how much is an apple plus an apple? 2 apples. Very good. And plus b squared. And that's how we get this. Now moving forward, I'm hoping that no one will ask, but if you do, I will answer. Nobody will ask, where does the 2 come from? Where does this 2 come from? From adding two terms that are like terms. That's where the 2 is coming from. So now if you want to understand this, and A and B doesn't have to be in there, right? So I'm going to call it the first term plus the second term squared. So let's take a look at this and understand the pattern. So this could be anything. This could be anything. FT stands for first term and ST stands for second term. Okay, can anyone tell us the pattern without foiling? What would you write? Very good. The first term squared plus?
The first one and the second of the second term.
I only have to follow this and write the same thing for first term and second term. 2 times, yes, first term times second term plus. That's it. That's all I need to remember. This is the pattern. So when I have a binomial squared, I have to square the first term plus 2 and multiply the first by the second plus the second term squared. What is this? What is the name of this? And how many terms I see there? Very good. This is a trinomial. So then from now on, we will always remember that a binomial squared will always equal. Very good, thank you. A binomial squared is always a trinomial. Again, this should not be confused with AB everything squared. This is not a binomial. This is one term, one product, AB squared. What will this equal to? That's it. This is the easy one. It's just a squared, b squared. It's a product. Very good. So this is our agreement. It's a squared plus 2ab plus b squared. Now I would like someone to give us an example. Just make one up. Make one up. Any example you want. You cannot say a and b. Go ahead, please.
3 plus 4.
That's not a binomial. 3 plus 4 is 7. Okay, so let's say 2x squared plus 4y cubed. So 2x squared plus 4y cubed. Good. So I'm following the pattern. The pattern says take the first term, which is 2x squared, and square it. So how much is 2x squared squared? 2 squared is 4. I copy the base, and what happens to the exponent? No, I don't add. Multiply, I agree. So this is 4x to the 4th plus. The middle term now. 2 times the first times the second. What will be the middle term? We're not going to write it like this. I'm doing it for the first example. Very good. Why x to the 4th? But they are different bases. I can't multiply anything. I multiply only when I raise to a power, number one. And here I'm multiplying two quantities, but they don't have the same base. I can't touch them. So it's x squared, y to the 3rd. No one can multiply x squared by y cubed. Good. Plus the second term squared. So now I have 4y cubed, everything squared. What will I have to write?
16 y to the 6th.
I copy the base. I do not add. I need to multiply when I raise to a power, to the 6th power. Copy the base, multiply the exponents, because it's 4y cubed times 4y cubed times 4y cubed. Right? Twice. 4y cubed times 4y cubed. So it's y cubed times y cubed. Copy the base and the exponents. Is this clear? Okay, let's choose another. And before we do that, can you please tell me what will change? What is the change here when the binomial has a negative in between? What will be the only change? Where? Only in the middle. A squared minus 2ab plus b squared. Only in the middle. Correct. Can anyone give us an example? Any example? Okay, 6x squared. But we're talking about minus. No problem.
Minus 2y to the 4th.
Okay, let's say y to the 4th. Very good. Okay, first term squared, please. Are you with me, everyone? Do you have any questions? Do you remember the power rules? Is there anything that I need to review here? Don't be shy. If you don't tell me, I will not know. Okay, so 6x squared squared.
36x.
Very good. Minus 2 times the first times the second.
2y to the 8th.
2 times the first times the second.
2, 6x to the 4th.
2 times 6 is 12. And then, yes, and then, very good, and plus the second term squared. Yes, y to the, do you agree with 8? Yes, copy the base, multiply the exponents. Y to the fourth, everything squared, copy the base, multiply the exponents. Is this okay? Do we need more examples from any of these? Two. Again, do you have to do this? No. But if you don't, you're going to have difficulties factoring. And if you don't, we're not going to make progress. I don't want to leave anyone behind. So this is really important. Just make yourself a tune. First term plus second term, everything squared is the first term squared plus 2 times the first times the second plus the second term squared. Just say it several times and it will stick. No question about it. Okay. So now let's look at the last one here. We have a plus b times a minus b. Let's FOIL it one last time. So a plus b times a minus b, and see what this is. So what can you do here? Yes, a squared. Very good. Let's FOIL it just this time. Indeed, a squared minus ab. Very good. Say it again. Very good. Apparently these two go away. And the answer is a squared minus b squared. So how will you remember this? ft plus st, first term anything it is, and whatever it is, and second term whatever it is. First term minus second term. So what would you say the answer would be? No FOIL. We left that beginning algebra behind. Very good. So this is called the difference of squares. Difference of squares. Difference of squares. A squared minus b squared. So can anyone make up an example so we can move on? Any example you want? And then we can start chapter 1 after this. Yes? Any example for me? Yes? Anyone? Okay. 2x minus 3y. What must the other one be? Of course. And what will be the answer? We don't want to FOIL. We refuse to FOIL. Very good. That's it. Very good. Any questions? So moving forward, please practice these. You can make up examples. You can play with these till you master them perfectly. Now, going this way is the distributive law. But what I'm more interested in is going this way, from here, here. From here, here, I distribute or use the special product. But what happens from here going backwards? What am I doing then? Indeed. That's the tricky part. That's the most difficult. Going backwards and factoring. But if I know that this changes into that and not FOIL it, if I continue FOILing it, then I will have tremendous difficulty going back to factor this. That's why I'm insisting now. Hopefully I convinced you to be able to use it or to understand the special product and use it going this way. So we will not have difficulties when we go this way. Okay. So let's start by looking at 1.1 graphs and TI-84, basically. So let's take a look at a couple of examples. Can anyone give us 3 different functions that you remember from your previous math adventures? I'd like you to give me 3 functions. And then we will choose one to graph. By hand, say it again.
X.
Good, that's a linear function. Very good, linear. This is the simplest possible linear function. There is nothing easier than this. Okay. Any other function that you can think of? Very good, that's awesome. Can anyone tell us what type of function is this? Yes, it is quadratic, awesome. Okay, let's look at one more. And I will make it up if you can think of one more.
X cubed.
True. Perfect. That's going to be in chapter 3. Perfect. I want to make one up. Let's say 2, the absolute value of x minus 1. What type of function is this? Of course. Once I said the absolute value, it has to be an absolute value. It's an absolute value function. And yes, we have other functions that we looked at in the previous classes, but for now, this is good enough. And I'd like to start with this. So f of x equals twice the absolute value of x minus 1. Okay. I'm asked to graph this function. So we're going to look at it and graph it by hand, and then look at the graphing calculator. I have a software here on this computer that they deleted from the other one that will allow us to, and I will show you, this was from my calculus class before you came in. So we're going to put the function in here and discuss it, how to graph it. Okay, so first of all, when I'm asked to graph a function, what is my first thought? Forever. Any function, forever. What would be my first thought? True, that is one. It's not the first one, it's the second thought. Perfect. What is my first thought? Say it again. No. No. Say it again. You're on the right track. I'm looking for another word, but you're on the right track.
Origin.
No? That's okay. So the first step for any function that I'm asked to graph is domain. Always. This is the input. So the input is what values I can plug in x, what values I can replace x by. Without knowing the input, I don't know where to graph this function. I don't know where it exists. When it doesn't exist, I have no news, right? No, nothing, no information. Okay, so domain. I'm looking at this function. I say to myself, okay, can I plug in 5? Yeah, because the absolute value of 5 is 5. 5 times 2 minus 1, I will be able to find y. Can I plug in 0? Yes, the absolute value of 0 is 0. 0 times 2 minus 1 is another number. Can I plug in negative 3? The absolute value of negative 3 is multiplied by 2 minus 1. So are there any restrictions? No. So what will be the domain then? Very good. All real numbers. Very good. The domain is anything. This is a friendly function. I can plug in whatever I want. Step number 2 is always a table of values, and I should say table of ordered pairs, in which I present the domain. I know you're used to presenting a tiny little vertical chart with 3 numbers in x and 3 numbers in y. No, that means nothing. So please don't do that. So I need a table like this. We're going to continue adding in this table a lot in chapter 3. And also 4. So this is extremely important. So this is a horizontal chart in which I have the domain on the x-axis, and this will be the function or y. So this is f of x. Now I'm going to pick some x values, and they will be somewhere centered around 0. Yes, your colleague is correct. Kyle, right? Kyle is perfectly correct. He said the x and y intercepts. This is always the case. I will always look for the x and y intercepts. Right now, I just want to get to show you how to graph this with a graphing calculator. So I'm just going to pick negative 2, negative 1, 0, 1, and 2. So let's plug in negative 2 in the function. So when I plug in negative 2, The absolute value of negative 2 is 2 times 2 is 4 minus 1 is, so I have to write 3 underneath. So let's repeat the process with negative 1. Very good. Do you all agree with 1? Let's repeat the process with 0. Perfect. Let's repeat it with 1. Very good. Let's repeat it with 2. Very good. And I can go on forever. So now I'm ready to graph this function. Can anyone give us the first ordered pair from left to right that I need to plot? Very good. Here it is. Negative 2, 3. Next ordered pair from left to right. Very good. Awesome. Next ordered pair. Very good. And then 1, 1. And then 2, 3. As we know about the absolute value, what type of function? Is there a, maybe not a mathematical term, but just a common term for the, or a name for this function? It's normally called, the absolute value function is normally called, it could be opening upward or it could be opening downward, but it's normally called a V. It's called a V function. You don't have to remember it like that, but just to have an idea. Very good. So now let's do this with the graphing calculator, just to show you, just to have an idea. So let's go and plot it in, put it in. So it's 2. Now the absolute value is under math and numbers. So click on math and then go 1 to the right. And what do you think ABS stands for? Absolute value. So go to math, to the right, and absolute value. And here is, this is the key for all variables. Here it is. And then go outside, and then negative 1. Before we look at this graph, I would like to come back for a second because I forgot to ask you to give me the range of this function. What is the range of this function? Very good. Awesome. So from the lowest y value till the largest y value. And we have to use a bracket because this point exists. So negative 1 to infinity. This is the range. Okay, so we're back for a second. And back to the graphing calculator, and just click on graph. And you will see the graph of 2 times the absolute value minus 1. Any questions on this? Yes, please.
I just have to one thing to understand. Why don't you get the range of negative 1?
From the lowest y value to the largest y value.
Oh, okay.
The lowest y value is negative 1 and the largest is infinity. Is that better?
Yes.
Good. Other questions? Other questions? Okay. Now let's move on to the next section, which deals with, so this is 1.2, linear and rational equations. Linear and rational equations. Okay, let's start with an example, and I will ask you what type of equation it is, because like we looked at the graph, we worked on the problem of graphing, or the request of graphing such a function, and I said, what is the first step? That must be the domain, always the domain. And then the table, and then the graph, and yes, the x and y intercepts are crucial as well. Okay, so I'm going to pick a problem from your book, and let's look at problem 10 on page 120, and this is 2 quantity x minus 1 plus 3 equals x minus 3 quantity x plus 1. You can throw at me any equation. I guarantee you the first question I ask myself is what? For graphs. That is for graphs and for functions. This is an equation. What do you think I am going to ask myself first?
What's that?
No? What type is it? There is a recipe for all different different equations. For a linear equation, there is one scheme or one method. For quadratic, a different one. For rational, a different one. For a square root or root equations, radical equations, a different method. For exponential, a different method. For logarithmic, a different method. For trigonometric, a different. Everything is different. So I have great chances of being able to solve this correctly if I identify it correctly. Because I don't know what method to use, right, if I don't identify it correctly. So what type of equation is this? This is indeed a linear equation. How do I know? It's because x has power 1. There are no products or variables, x times y. And there is no x in the denominator. So condition number 1, all powers for x are 1. All powers are 1. Condition number 2, no x in the denominator. No x in the denominator. Condition number 1 again, all x values have variables or variable. All x, every time x appears, it has power 1. Number 2, no x in the denominator. And condition number 3, no product of variables. Now, no x times y. X times y will not be a rational, will not be a linear equation. Good. Now the question is, how do I proceed? I identified it correctly. I have great chances of solving it correctly. How do I proceed? I must do what first? Linear equations are not solved by setting them equal to 0. Quadratic equations require them. Distribute. So then I have 2x minus 2 plus 3 equals x.
Minus 3x. Or minus 3.
Do you agree with this step? Everyone? Do we agree with this? Okay, perfect. Now, what do you think will be the next step? Nope. Indeed. What I like to say is clean it up. Of course, I mean simplifying it. But maybe that will trigger your memory. We have to completely simplify both sides before we try to move terms around. Okay, the left-hand side is 2x plus 1, indeed, and the right-hand side is? Awesome. Now I'm ready to move terms around, and yes, I have to separate the terms with x from the terms without x. This is not a type of equation in which we have to set it equal to 0. So when I move a term to the other side, and I recommend you do this instead of writing so much, I recommend this, but of course use the method you like. When I move a term from one side to the other, I only change its sign. So when I move this here, it becomes positive. So 2x plus 2x is 4x. And when I move positive 1 to the other side, it becomes negative. So this is negative 4. Therefore, the final answer is negative 1. Do you think we got the picture with linear equations or we need another? It's okay if you say we need another, but I need to know. Should we look at one more?
Sure.
Okay, here's one more. Let's say 28 on page 120. 5 plus x minus 2 divided by 3 equals x plus 3 over 8. What type of equation is this? Never, because it doesn't have x in the denominator. As long as it doesn't have x in the denominator, it can never be considered rational. A rational equation must have x in the denominator. Okay, what do? I look at this equation and I say, oops, I really don't like it because, why I don't like it? Because it has fractions. But I should never ever worry about those. Why? Because I can always yes, I can always get rid of them. How? Both sides by the least common denominator, which in this case is? Very good. 3 and 8 have nothing in common, so the product will be the least common denominator. Very good. Remember, we have to multiply everything by 24. So here is times 24, but here I would like to write it as 24 over 1 so I can simplify. Here I would like to write it also as 24 over 1 so I can simplify. Are you with me, everyone? Everyone? Yes? Yes? Stop if you have questions. I would not know to stop unless you tell me to. So when I multiply 24 by 5, I get, is it 120? Good. Plus, look what I do next. Divide this by 3 and I get 1, not 0, careful. And I divide this by 3 and I get 8. So I will write it as 8 quantity x minus 2 for now. Now can you mimic the right-hand side for me?
3 parentheses x plus 3.
Do you all agree with 3 parentheses x plus 3? Yes? Very good. Perfect. So this is 3. X plus 3. How did we get that? 8 divided by 8 is 1. 24 divided by 8 is 3. Although initially it seemed a difficult situation, a different equation, it's really not. Because now we're back to where we were with the previous problem, correct? What will I have to do next? Here? Distribute. So 120 plus. Very good, awesome. Good. Please combine like terms and simplify both sides. I recommend keep the variable on the left. It's not a mandatory requirement. It's not, you don't have to. Sometimes we may keep it on the right hand side, but on the left hand, on the right hand side, but I highly recommend keep the variable on the left. So 8x and then plus 104 equals 3x plus 9. I will be moving 3x and I will be moving 104. All I have to do is change their sign. 8x minus 3x is good. And then 9 minus 104. Okay. Finally, x equals negative. Good. Any questions on this linear equation? Any questions? Okay, so let's continue with the problem like 77. Any questions for me? Please remember to redo these problems before you work on more problems like these. Please. Okay, so let's look at 77 on page 120, not 124, but 121. Okay, here's the problem. 4 divided by x minus 2 plus 3 divided by x plus 5 equals 7 divided by x plus 5 times x minus 2.